Hello students, we are starting 7th chapter alternating current today and in the first assignment 7.0, we have mainly two topics, complex number and few terms, resistance, reactance and impedance. These are actually prerequisites for this chapter, not part of the chapter, but it's better to understand these things before starting chapter. So it is actually prerequisite assignments. Complex number is part of maths, but it's better to brush up that part for math student and for biology student it is essential that they understand this. So in this video we'll try to understand what is complex number and how to deal with complex number. In next video we'll talk about the three terms resistance, reactance and impedance. So let us start with what is complex number. We know that in maths we have numbers like 0, 1, 2, 3. All these are called real numbers. Now at the same time there are numbers uh, where we face some difficulty. Like if you are asked what is square root of 16, you might find it a trivial question. Square root of 16 is 4. Actually incomplete answer. Square root of 16 may be plus 4 or minus 4. So it is plus or minus 4. Now, if you take square of 4, answer is 16. If you take square of minus 4, answer is 16. But what if you take square root of 4 plus or minus 2? What if you take square root of minus 4? Problem. What is the problem? Square root of minus 4 is not minus 2. Square root of 4 is plus 2. It can be minus 2 also, but square root of minus 4 is not minus 2. So how do we express it? So square root of minus 4, if you have to find, we can split it as minus 1 into 4. So I'll write it as square root of minus 1 and square root of 4. Assuming square root of 4 is plus 2, this number is given symbol I in maths. So square root of minus 4 is I 2. You can write plus or minus 2 also, it's okay, fine, no problem. So such numbers are called imaginary numbers where square root of minus 1 is involved. So what are the imaginary numbers? Square root of minus 2, square root of minus 1, square root of minus 16 and so on. All these are called imaginary numbers. Okay, so on one hand you have real numbers and then you have imaginary numbers also. And combination of these two is called complex number. Okay, so what is complex number? Complex number is a number which is having some part real and some part imaginary. Okay, so if I am told that z is 2 plus I 5, I should understand that what I am talking about is 2 plus square root of minus 1 into 5. Okay, and this 2 cannot be added. You cannot write this as 2 plus 5 as 7. Okay, the way you have x component and y component of vectors, real and imaginary part both are separate entity. You cannot add or subtract them directly. But if you have z1 as 2 plus I5 and z2 as 3 plus I2, and then if you want to find out z1 plus z2, you can happily add real with real, so you'll get 2 plus 3 as 5 plus imaginary with imaginary, so 5 plus 2 as 7. So in addition it is possible, but not otherwise. So this is a complex number. Okay, what is complex number? A number in which you have real part and imaginary part both. Now what we need to know about complex number at this stage is which are the different ways of expressing complex number. First thing, how do we multiply complex number? Addition is very simple, okay, but multiplication, uh, we should be careful about certain things. So first, let us try to understand presentation of complex number, how to represent it, how to express it. So for that, we'll again try to recall one of the previous topics, vectors. In 11th standard, you must have studied vectors. It will help us understanding presentation of complex number. We know that vector r can be expressed as xi cap plus yj cap. Similarly, complex number is conventionally denoted by letter z, and you can write it as a plus I b. Now be careful. I cap and j cap are unit vectors along x and y axis, whereas this I, it is not I cap, it is I, is presentation, it is representing square root of minus 1. So wherever you have I cap, you should understand, sorry, wherever you have I, you should keep in mind that you are talking about square root of minus 1. Now, vector R can be presented, you can represent it on Cartesian plane. What is Cartesian plane? Where you have x and y axis. How do we present it? So we take x on horizontal axis, y on vertical axis, and then we say that this line is vector r and this angle is direction of vector r. Very similar thing we have in complex number. In complex number, we don't have Cartesian plane. The plane or surface here is called complex plane, where instead of x-axis you have axis called real axis. Vertical axis is known as imaginary axis. Okay, but presentation is very similar. Instead of x now I have a, instead of y I have b, and then I would say that this line is representing my complex number z, and this angle is known as phase of complex number. The way you have direction, sorry, the way you have direction in case of vector, in case of complex number it is phase. So x can be written as r cos theta, a can be written as mod z cos delta, y can be written as r sin theta, imaginary part of complex number can be written as mod z sin delta. Direction of vector can be expressed as y by x. Phase of complex number, sorry, phase of complex number tan delta can be written as imaginary part by real part. So see how many similarities we have. You can write r square as x square plus y square, or r as under root of x square plus y square. Similarly, z square magnitude of complex number can be written as a square plus b square, or else you can write mod z as under root of a square plus b square. So all these are similarities. You can write r, vector r, as r cos theta I cap plus r sin theta j cap. So z can be written as mod z cos delta plus I mod z sin delta. Sorry. So this is one way of presenting vector. This is one way of representing complex number. This is another way of expressing a vector. This is another way of putting a complex number. So two ways of expressing complex number so far. Now There is slight difference. In this case, if you take mod z out, you will get cos delta plus I sin delta, and this thing is represented as e raised to j delta in maths. So it is mod z e raised to j delta or I delta. In maths, it is I delta, but in physics, we will be using j to represent complex square root of 1 because I is used for current. So pardon me if somewhere I have used j instead of I. But don't forget that I square is square root of, sorry, I is square root of minus 1. I square is minus 1. Okay. So sometime I may write j instead of I. It is just change in symbol, nothing else. So these are the three ways of expressing a complex number. First one is if you know real and imaginary part of the complex number. Second way is to express in terms of z and delta, sorry, magnitude and phase. Third one is called exponential form. So these are the three ways of expressing any complex number. Now, what if I want to multiply two complex numbers? So, no, before that, let us try to convert from one form to another. Let me take one example. So, if I consider some complex number, say z as 5 plus I3. So, this is my A and this is my B. So, I can convert this, I can represent this on complex plane. Where should I take 5? So as it is a real part, I can present 5 here. I can take 3 here, and then I would say that this is the z. This is what we have done. We have represented the given complex number on complex plane. Now I know that mod z is under root of a square plus b square. So in this case, it is under root of 5 square plus 3 square, that is root 24, and 10 of delta is opposite by adjacent or imaginary part by real part. Okay, so delta is 10 inverse of 3 by 5. So once you have mod z known, once you have delta calculated from table, you can easily write z as mod z cos delta plus I mod z sin delta. Not only that, you can also express it in form of exponent j delta. So find out mod z, find out delta, substitute here, and you have two other ways of expressing this complex number 5 plus I3. Okay. Similarly, suppose if you are given say mod z as say 2 plus e raised to I 90. Normally angle will be given in terms of radian. If not, you can convert it. Find out other two forms of this complex number. So what I can do is from this equation, when I compare it with standard form, I realize that mod z here is 2 and delta is 90 degree. Okay. So what is real part? A is mod z cos delta, that is cos 90 in this case, so 2 cos 90. B is mod z sin delta, that is 2 sin 90. You can find out A and B, and then you can write z as A plus IB. So this is one form. What is the other form? Other form is z is equal to mod z cos delta plus I mod z sine delta. So you have mod z and delta available here. You just have to substitute it. Okay, so z is 2 cos 90 plus I 2 sine 90. You can simplify this. So these are the two other ways of expressing this complex number. So central idea is if you are given one form of complex number, you should be able to convert it into other form. One more thing we should be knowing about complex number is multiplication of two complex numbers. So if I have z is equal to say 2 plus I3, say z1 and z2, if it is 4 plus I say 5, if I am asked to find out z1 into z2, how do I multiply this? So 2 multiplied by 4, 2 with I5, I3 with 4 and I3 to be multiplied with I5 as well. 2 into 4 that is 8, 5 into 2 is 10 with the I 3 into 4 is 12 plus I into I is I square and 5 into 3 is 15. So 8 plus I10, I12 that is I22. Now recall what is I. I is square root of minus 1 and what is I square? It should be minus 1. So I can write this as minus 1. So minus 1 into 15 that is minus 15. So 8 plus I 22 minus 15 and then I am left with minus 7 plus I 22. This is Z1 multiplied by Z2. Okay. So this is how you can multiply any two complex numbers. You just have to be careful in this one step. One more thing we should be knowing about complex number is complex conjugate. What is complex conjugate? Complex conjugate is a number where sign of imaginary part is swapped, is changed. So if the number is IB, A plus IB, complex conjugate of this number is denoted by Z star. It is nothing but A minus IB. Okay, so if you have a number like say Z1 is 2 minus I5, what is conjugate of Z1? It is 2 plus I5. If you are given Z2 as minus I3, what is conjugate of Z2? There is no real part, so simply plus I3. What if you are given complex number Z3 is simply 5? There is no imaginary part, only real part. So you don't have to do anything. It is 5 only. Conjugate is the one in which sign of imaginary part is changed. The real part remains unaffected. So if I take Z star, let us see what do we get. So A plus IB to be multiplied with A minus IB. So A with minus IB plus IB to be multiplied with minus IB and IB to be multiplied with A. So this 2 will be mutually cancelled out and what you are left with is A square plus I square into minus B square. See, you have B and B, that is B square. You have I into I, that is I square, and then you have this minus sign also. Okay. So what should I write now? Now this I square is minus 1, and with this negative sign I have plus 1. So it is a square plus b square. So this is slightly different as compared to our normal multiplication of uh, a plus b into a minus b. Suppose if you have two numbers, a plus b multiplied with a minus b, what do we get? A square minus b square. But see here, z star is a square plus b square because I square is minus 1. So that is one more difference when you are dealing with complex number. And this is all you are supposed to know for now about complex number. Prepare answer to these questions. What is complex number? Complex number is a number in which you have both real part and imaginary part. In terms of real and imaginary part, so this is how you can express a plus ib. Okay, in terms of magnitude and phase, so this is magnitude and phase. In terms of exponential form, this is exponential form. Okay, this is exponential form, magnitude and phase in terms of real and imaginary. So these are three different ways of expressing a complex number, and then you should be able to convert it from one form to another. So that is all we need to know about complex number, and that is all for now. Thank you.